Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning to all of you. Some of the faces here are not new to me, while others are new. Okay? My name is Lukman, and today I will present this topic, which is the significance of the basic engineering concepts. I would have called it basic mechanical engineering concepts, okay? Because I will narrow down my discussion to basic mechanical engineering concepts, because this seminar is organized by the ME Club. As a disclaimer, I am not a mechanical engineer, okay? I'm a civil engineer by professional training. However, I happened to be in charge of the mechanical engineering department from 2015 to 2017. I was the head of the mechanical engineering department. So during that time, I was exposed to many things that I didn't know before about mechanical engineering. So for that, I may have some few things to tell you this morning, okay, concerning the basic concepts of, mechanical engineering. And then during that period, when I was heading the mechanical engineering, I interviewed many professors seeking to be employed in the department as professors of mechanical engineering. In fact, I can tell you that I have attended maybe over 100 interviews, 100. And definitely that will give me a lot of exposure and experience, okay? And then, apart from that, we also organize, when you graduate, those seeking to become GAs, the graduate assistants, the MUID, we form exams for them, okay? I also happen to be one of those that form those exams at that time, okay? So I know exactly the type of questions we set, because the exams are for those that have BSc, BS, and MS, okay? For the PhDs, they don't sit for exams, they sit for interviews, okay? So these are two things. Another thing that is the motivation for this topic, I realize, that most of the students here, when they finish a particular term or semester, they delete whatever they learned in that semester at the end of the exams. And they think they will not use it again, ever again in their life, okay? You see this habit, in the exams hall, when they throw away the lecture notes, even the textbooks sometimes. That was the time when you were giving free textbooks. They throw away the textbooks and say, no, I will not need it again in my life. That is wrong. That is wrong. And that is why I feel this morning there is need for me to stand up before you and not tell you something that you don't know. Okay? I will not tell you something new. I will only emphasize about what you already know. That's why we say significance. That's the importance of the basic engineering concepts. To highlight the importance of those basic engineering concepts. First of all, what are these concepts? We will go, one after the other. What are these concepts? Mechanical engineering, basically, you can broadly classify it into three. You have the mechanics, consisting of the statics and the dynamics. Although the mechanics also, you have to have the fluid mechanics and the solid mechanics, okay? And then you have the thermodynamics, or the heat, or the energy, which sometimes they are lumped up together with the fluid mechanics. under energy, because energy, you consider the thermodynamics aspect, the heat transfer, and you consider the fluid mechanics aspect as well. Okay, and then you have the materials or production, which is more or less looking at the material science and what have you, and the manufacturing. Okay, these are like the three broad classification that you have, even at the senior level. These are the specializations. You have the energy, the solid mechanics, and the production or manufacturing. Okay? So, what I realized from my experience over these years, that these basic concepts that you learn at the sophomore level, the junior level, I know most of you are now maybe in the sophomore level, the junior level, some may even be in the senior level. There are some of them that you are not expected to forget. In fact, it will be a crime when you forget them. How is it a crime? Because you can always be tested on these basic concepts at all times. And when you don't, present them as they are, you can be penalized. How? Let's say for the interview, when you're asked, okay, you sit down, you're asked to state the first law of thermodynamics. You finished first degree, second degree, third degree. And only for you to be asked something in maybe Thermo 1, ME 203. Probably that's where you learn first law of thermodynamics, isn't it? Yes. Do you understand? Having finished all your studies with deep knowledge, advanced knowledge, but no, they go back to the basics. What is first law of thermodynamics? I don't remember how many times I ask professors this question. So I'm not telling you like hearsay. No, I ask this question. And when they don't explain it to my satisfaction, that will be a big minus. Because even if you're a professor of mechanical engineering, you should not forget the basic concepts. That is to say, even if you are a graduate of mechanical engineering, you should also not forget the basic concepts. Do you understand? We test you on the basic concepts. We don't go deep, no? The basic concept that should always be at your fingertips. That even if someone wakes you up and asks you, state Newton's law of cooling, you should be able to tell him and just go back to sleep without thinking twice. Don't worry, I will start asking you, we will start looking at some of these basic concepts from the mechanics point of view to the thermodynamics point of view. And then you ask yourself that, am I up to date on all these basic concepts or not? It's still not too late. It's still not too late. You can still go back and review these concepts. It's just about, I always tell my students, it's about understanding, not memorization. That is what engineering is all about. It's not like the arts, the management, where you will have to memorize certain wordings, certain paragraphs to memorize them. No. In engineering, it is not about your power to memorize. It is about your power to understand physical phenomena. That is it. And that is why we take our time to explain things, the basic concepts, so that you understand them. When you understand them, that is it. You go back and sleep. But they are not supposed to be out of, your own understanding. So that at whatever time you are asked to reproduce, to explain, you should be able to do that. You should be able to do that. I will start with some of the basic concepts, which my students here, they know I always emphasize every of my class about the basic concepts. I ask a lot of questions. So, like I mentioned to Ahmad when he first confronted me about the topic, I said, it will be like a normal class. That's why I don't have any PowerPoint slide. Because it will be more or less like an interactive session where I'll be asking you questions and you'll be responding to me like that, where I will be highlighting some of these basic concepts. Let's start with mechanics. Mechanics is the bedrock of mechanical engineering. Bedrock is the bedrock of mechanical engineering. Mechanics. So you must understand the basic concepts of mechanics very well. And mechanics, as we all know, is composed of, now I will start with my question. Mechanics is composed of what? Just tell me.
What's the question?
Mechanics is composed of what and what? Mechanics is made up of what and what? Just give me one. Yeah, mechanics.
Moving.
Which level are you?
3.
Freshman? No. Mechanics is made up of what and what? Mechanics.
It's about just moving. Rotation.
Any other idea? What about you? Can you help him out? Mechanics. Mechanics is made up of what and what?
The science of motion, the science of equilibrium.
The science of motion is called what?
Motion.
Yes.
Motion direction.
Dynamics. Dynamics. So now, dynamics and what?
The thermo.
The other part of mechanics is what? No?
Thermodynamics.
No?
Static.
Statics.
Equilibrium.
Statics. At the basic level, you have statics plus dynamics equals mechanics.
Mechanics, yes.
Do you understand? This is where it starts. Statics plus dynamics equals mechanics. Now, what are some of the basic concepts in statics? The basic concept, or the concept of both mechanics and dynamics is the Newton's laws of motion.
Yes.
The 3 Newton's laws of motion. These laws, you should always be able to explain them. Some of you are juniors here. You must have done it in your high school. The same thing was repeated probably in the prep year. And then in the freshman. The same thing in the junior, sophomore level. And now the junior level.
Yes.
Do you understand? There is reason why it is being repeated and repeated and repeated. So that, one, you have a better understanding of what these laws are. And 2, so that you don't forget them in your life. You don't forget them in your life. I don't know how many times I ask professors during interview to state one of the Newton's laws of motion. You can imagine. You finish your PhD in civil engineering, in mechanical engineering, only for you to be asked to explain how Newton's first law of motion is used in equilibrium condition. Do you understand? By the way, what is the Newton's first law of motion? Let's start with that one. Newton's, just explain in any way that, yeah, you, with black.
What's your question, Victor?
What is Newton's first law of motion? That's why I told you it will be interactive. I'll be asking you questions and then I will be emphasizing. Okay? These are the things that should be at your fingertips. What is the Newton's first law of motion?
I know it in Arabic.
You have to know it in English. Because you were taught in English, isn't it?
Yes.
So you have to know it in English. Just explain it in any way. What about you? Can you explain it in English? Newton's first law of motion.
Each force acts the
No.
expect force the which the one
What?
the when the force
Okay, explain it in Arabic. And then someone will translate it to me in English. Explain it in Arabic. No, No, I want that guy to explain. Explain it in Arabic.
Yes, yes. But it's still
constant if there any force
the summation of force equals 0.
The summation of force equals 0. Yeah,
Because
yeah,
acceleration equals 0.
yeah, that is like a mathematical way to express it. But what does it say? It simply talks about this is not moving, isn't it?
Yes. I say it in Arabic.
Okay, it is static.
Yes.
Static at rest, isn't it? So it remains at rest until it is acted upon by an external force. When I push it, that's an external force. Simple, isn't it? So when it is at rest, the sum of all forces acting as he mentioned is equal to 0. But the resultant sum of all forces, the resultant, because I can be pulling from here, another guy can be pulling from there. When the forces are equal, they cancel each other, isn't it?
Yes, yes.
Now, what will happen if the one force is greater? It will move
Yes.
in the direction where the force is greater.
Second
Now, I will ask another person. Yes, new face. What is the second law of motion?
is not
The first law, what?
is not mechanical still.
Don't worry, it doesn't matter. Are you an engineer student? Oh, then
Chemical engineering.
chemical. Yeah, chemical are not taking statics, but you did this in physics, isn't it?
Yeah.
So you can tell me something, probably. Okay? You see, the first law is the bedrock of statics. Statics is built on the first law. Do you understand? Now, the second law. Can you tell me something about it? Can you remember anything?
No, I remember it, but I can't say it in English.
This is one of the problems that this is another problem that you have to work on. Most of the students now are having tough time writing in English, writing sentences in English, sincerely speaking. The former students that we had, their English level is slightly better, but now the level is decreasing. Sincerely speaking, you have to work on that. You have to work on improving your level of English language. I know some will say, if I finish, I will just get a job and I will be speaking in Arabic. But some of you may say, I want to go abroad for my master's degree. I want to go for my PhD. Isn't it? Where your English language has to be very good. Do you understand? So, do all that you can now to improve your level of English language. There are many websites that can help you online. And even amongst your friends, make it a duty. When I come to school, no Arabic, only English. They will laugh at you and all that, but you'll be improving. Get your friend, be speaking, be correcting each other. And then this is one of the ways. Your English level, some of you will be speaking English, good English, but writing, that is terrible. Do you understand? This is not funny. You must improve your level of English language. Because in engineering, it is not in Arabic. Like the management, isn't it? Management is in Arabic, so you have no issue with that. But engineering, everything is in English. That is the language of instruction. English is not my mother tongue language. I also learned English. I have another language different from English. Do you understand? Except that I learned it, right from, the growing up, right from the primary school, the high school, everything was in English. Okay? But you have to put a lot of effort. It is very important. Some of you, are very good, but the level, that some will say, no, I know it in Arabic. What about if it is exams? Do you get my point?
Yes.
Exams are written in English. When you write in Arabic, you even if you get it 100% correct, you get 0. Do you get the point? So you have to improve your English language. This is very important, very important. So, yes. Second law. Yes. Can you tell me, explain to me the second law of motion? Newton's second law of motion. Are you mechanical? Okay. Just in any way that based on your understanding. Yes? Can you help me out? You, yes. F equal MA. That is the mathematical expression. Yeah, this is one of the ways. Okay, at the end, F equal MA. But when I pull this, it is moving. Then the second law is saying that it will move in the direction of the applied force. And it will accelerate. And that acceleration is proportional to the applied force. So at the end, you have F equal MA. Isn't it? You have F equal MA. And then another condition for equilibrium is when the body is moving with uniform velocity. If the body is not accelerating, then it is moving with uniform velocity. So acceleration is equal to 0. That is also a problem under statics. This is very important. Then the third law. This we all know the third law.
Yeah.
What is it?
Every reaction has a reaction opposite in the direction they call and
Action and reaction are equal and opposite, isn't it?
Yes.
This we all know, okay? And this we also apply it in both statics and dynamics.
Yes.
Newton's laws of motion, in case some of you might have forgot about them, please go back and review them. They are not something that are very difficult, that are difficult to understand. No, they are straightforward. And all these concepts have been applied in statics and dynamics. So there are things that you know, but you are not expected to forget them. Because they form the bedrock of mechanical engineering, the bedrock of statics and dynamics. From statics and dynamics, where do you go next? You go to machine design. That is the application. You go to machine design. In machine design, you apply the material science and then you apply the statics and dynamics principles. From machine design, you have machine design 1 and 2. Then you go to mechanics of machines. You go to mechanics of machines. Do you understand? So there are not things that you joke with. This is in addition to fluid mechanics that you have as well. Do you get the point? Now, another very important basic concept here. So I will be like touching from both the thermodynamics and the mechanics. The laws of thermodynamics. Can you state the first law of thermodynamics? The first law.
The energy.
I don't know.
Energy.
First law of thermodynamics says what?
Energy.
Just explain it to me in any, based on your understanding.
Energy cannot be created or
Energy cannot be
created
or
destroyed.
good. Simple. But can be changed from one form to another. It's also called the law of conservation of energy, isn't it?
Yes.
Or the energy principle, or first law of thermodynamics. This simple law, as you hear it, we ask professors to state the first law of thermodynamics. Not you, professors that have finished their life in the area of thermodynamics. Yet, they are not too big to be asked the simplest question of thermodynamics. Do you understand? Energy can neither be created nor destroyed. And this is one of the most important law in engineering. One of the most important. Because from there, a lot of things are created. A lot of things are created. Probably you have started dealing with the thermodynamics too and heat transfer. Okay? Maybe now, what about the second law of thermodynamics?
Conservation of energy.
No, I'm asking this guy. Or do I jump to another one?
yes,
Oh, now you can, okay, let me come back to you.
delta S is bigger than 0 entropy.
The entropy of a system increases, isn't it?
Yes.
When it is a natural system, isn't it? So it's always tending towards this orderliness, isn't it? Just like you have, let's say, fluid flowing from higher energy level to lower energy level, not the reverse, isn't it? For the reverse, you need to supply energy to it, isn't it? To make it overcome the energy barrier. Correct? This second law, we ask professors to explain it to us. And some, some may say, I forgot. But that is not an excuse to us. We will not take that as an excuse. You forgot? No way. That is your area of specialization. So, this is a basic concept that you must not forget. Do you understand? I'm highlighting all this because, like I mentioned, I'm not saying all of you will aspire to become faculty members, but surely some of you will aspire to become one. Some of you will aspire to go to the industry and all that, where, the big industries, they will give you examination, isn't it? Before you are recruited. And these examinations are not testing your deep knowledge, but the basic knowledge. Basic and simple knowledge that at any point in time, you should always remember them. You can imagine sitting for an exam after you graduate. Are you going to take all your textbooks and review them for that exams? All the courses that you took throughout the BS?
You can't do it.
You cannot. So definitely you have some residual knowledge that should always remain with you at any point in time. Do you get the point? So another thing I'm emphasizing, when you take a course, do it with passion. Don't do it as if I just want to get A+ and that's it. When I get A+, I can delete the knowledge I derived from the course. I will not use it again. No. Do it with a passion that you want to gain the knowledge in this course. And then, of course, in the process, when you do it right, you will get the A+. Because as I always tell my students, A+ is manufactured by you, not by the faculty, not by the instructor. The A+ is manufactured by the student. If the student is able to manufacture the A+, the faculty has no option other than to stamp it and approve it. No matter what, he cannot deny you that A+. So you manufacture the A+, not the instructor. So we talk about first law of thermodynamics, second law of thermodynamics. Now, I'll go a little bit deeper. What about the Newton's law of cooling? Can you tell me the Newton's law of cooling?
Give us, Doctor, at the surface, Doctor.
Well, this is the surface. This is high school. I didn't take Newton's law of cooling in the university. I took it in high school. Sincerely speaking, I took the Newton's law of cooling in high school.
Cooling?
Yeah, in high school. In high school, not in the university. Newton's law of cooling.
A little reminder, Doctor.
It's about hot bodies,
Yes,
radiation, the rate at which heat is lost
Yes. Heat
from a
go
hot
from
body,
hot to
proportional to the
different
in the temperature. Okay. It's not something that you should have it clear in your mind.
we forget the name, Doctor.
Newton's law of cooling.
Yes, we know it, Doctor.
Okay.
The application we know it, but forget the name when we use Newton law of cooling with this. But the application we know it. Heat.
So what do you call it?
I don't call it actually. I know it, but I don't.
Then you should know the name.
Yes.
You should know the headline.
Yes.
Okay? Very important. Because like now, you can go to an interview and then you'll be asked, state Newton's law of cooling. And then you cannot say, what is, do you get my point?
Yes, yes.
Okay?
That's a good one.
Yeah, very good point. And then, of course, there are a lot of other basic points. We talked about the Newton's laws of motion, which form the bedrock. Okay? Like, for instance, someone can ask you, what is the difference between pressure and stress? What's the difference between pressure and stress?
pressure, the weight of air, and the stress, the force applied on the surface at some specific point. but the pressure may be on all the surface, not in the specific point, like the force or the stress.
Can someone modify his, he has some understanding about it, but can someone modify it, improve on what he said? Oh,
This is the wrong.
this is pressure. Or stress. Which one? Which one?
Pressure.
Huh? Stress for solid. Okay. And
Pressure for fluid.
pressure for fluid. Like this is something simple. Stress and pressure. What about the relationship between pressure now and energy? Yes. For those of you taking my fluid mechanics, because we treated pressure and stress, but we haven't reached a point where we'll treat pressure and energy. So now I will test your understanding.
Energy, Victor, the ability to do pressure.
What's the relationship between pressure? Because some are taking pressure as energy, which is not the case. Pressure is not energy.
No.
So
but
how are they related, pressure and energy?
energy causes the pressure.
The pressure.
No, the pressure
Cause the energy.
cause
Because
the
it's changed the
العكس.
state.
يعني انت لما تطبق البريشر يصير عندك طاقه.
If you don't have energy,
Pressure
you can't create
is
pressure.
the measure of the energy content per unit volume. Is the measure of the energy content per unit volume. But pressure itself is not energy.
Yes,
But like giving you how much energy the body has per unit volume.
Yes.
So this is how they are related. But don't worry, for those taking my fluid mechanics, we will reach there soon. Okay?
like a-
Where we'll explain that. But these are some simple questions. Do you get my point?
Yes, yes.
Simple yet basic that you are supposed to understand. Now, let me take you something else. Again, let me ask you something else. We all know about free body diagram, right? And we all know, again, about force diagram.
Yes.
What is the difference between the two? Between free body diagram and force diagram.
The
We have been using free body diagram,
yes.
but then later, under momentum, for those taking my fluid mechanics, we'll be using force diagram.
Doctor, the force diagram we shows the acceleration of the body.
on free body diagram we will determine only the force act on the body, but without the real
Force
shape
diagram
of
we
the-
shows the mass times the acceleration. We represent it as arrow.
Okay, then before answering this question, let me take you back to another important principle in mechanics, the Lagrangian approach and the Eulerian approach.
What?
You seeing what? Lagrangian approach and the Eulerian approach. Lagrange is, this is the name of a scientist, Lagrange, and Euler is another name. Okay, for those taking my fluid mechanics, we haven't treated it yet, but we will. But maybe there are others. What?
This is from future.
No, not future. In fluid mechanics. We'll do it in fluid mechanics.
Until now we didn't take it.
Yeah, but this is not my fluid mechanics class. There are other students, from, maybe higher level that have already done, they already took fluid mechanics, isn't it?
Know about it, yes.
The Lagrangian approach and the Eulerian approach, there are two basic approaches, in mechanics, in formulation. We use it in formulation. In the Lagrangian approach, we follow the movement of individual particle. In the Eulerian approach, we choose a region in space and then observe the motion of matter. The free body diagram is using the Lagrangian approach, and the force diagram is using the Eulerian approach. But for those of you taking my fluid mechanics, don't worry. We will take that in deep, okay? But for those that are like say in the senior level and all that, they should know this. Lagrangian approach and the Eulerian approach. We use it in the derivation of a lot of mathematical formulations. Okay? And they are the basis behind using free body diagram or force diagram. Do you understand?
Yes.
Okay? So these are some of the basic concepts. Like, all I'm trying to do now is only like to pinpoint, to highlight some of these basic concepts that you truly need. What about intensive and extensive properties? Very simple.
Yes.
Oh, yes, but let me hear you out. What is intensive property? Yeah, as simple as it is, we ask these questions in the exams or during interviews. As simple as they are. Do you understand?
Yes.
What is intensive property?
The theorem one. The theorem.
Theorem of physics.
What is intensive property? What is intensive property? What is intensive property? Oh. They have all forgotten what is intensive property.
No. Same here. This is one dependent volume, another not dependent volume.
Yes.
Doctor, size, mass, color, temperature,
Yes.
What?
they not defined.
What is intensive property?
Doesn't depend on the volume of the volume that contain the material.
Does dependent volume.
Doctor,
If you define
Ahmad, it's time for you. This question is for you. Okay. What? What? Let me come closer. What is an intensive property? This is a very simple question that, I mean,
mass,
Dependent mass or another not dependent mass. I think that.
you are like guessing. You should be straightforward and direct and tell me intensive property is a property that
doesn't it change when you define the material? Doesn't change when you define the material.
so it doesn't depend on mass,
Yes.
not volume. You are saying volume. And the other extensive property depends on mass.
yes,
Now, give me example of intensive property.
Intensive
Property.
property. Mass itself.
intensive,
Pressure.
Mass
Density.
is
Density.
temperature,
Okay.
Mass is not an intensive property.
with the question.
Mass is
You just chuck point out this.
So, I mean, you can see how simple question, you can like answer it wrongly, isn't it?
Yes, but not like this. Ask me for 1 second, doctor. It's not-
During interviews like this, I will just ask, okay, what is intensive property?
Take my time, maybe 10 seconds, 20 seconds to think, then I will tell you the answer.
No, during interview, you don't have that luxury to be thinking and thinking and thinking.
No, not, I said 10 seconds, doctor. Not,
Okay, now, give me example of an intensive property. Temperature, pressure. Okay. Give me another example of intensive property. Volume?
Dependent mass.
Okay, example of extensive property. Extensive. Okay, mass.
size, volume.
Okay, what else? So, okay, now, closed system. An open system.
This one I will answer.
You will answer it straight, without thinking. Huh? Now you are not taking pictures.
Constant volume.
Huh?
Constant volume.
Close,
What about, can matter be exchanged in a closed system?
there is
Because
It's closed. What about heat and energy? Can it cross the boundary of a closed system?
Yes.
Yes. What about in open system? Can matter be transferred in an
Mass
open
and
system?
heat in open system can transfer.
In open system?
Yes.
Okay. So, do you feel like challenged now?
yeah.
On some of the basic things? Then you feel, what?
Am I taking?
So, these are some of the basic concepts and their importance. All the most important, the complicated thermodynamic concepts are built on this. for those even taking my fluid mechanics, we will still discuss about the intensive and extensive properties as well as the open and closed systems. And then you have already treated them in thermodynamics. And then that will be the basis for a lot of other formulations. You are not supposed to forget them. We ask these basic questions. We ask not, GAs, we ask professors. So they are not things that you should always have a clear picture of what they are. Clear picture of everything that we that we discussed from the beginning. Not only these simple ones, because these, they appear to be very simple, so you always get them. Like now, if I will ask you to state the Newton's law of gravitation. Who can state the Newton's law of gravitation?
The formula you want or
No, to explain to me what is the Newton's law of gravitation?
It's measure the force of attraction between two bodies.
Yes, over the distance between them.
The square distance, the square radius between.
G equal F equal G m1 m2 over r squared, isn't it?
Yes.
Okay, so it's equal to the product of their masses, and it's proportional to the product of their masses and the inverse of the square of their distances apart. Okay, that is one. So I have highlighted some of these basic concepts. Now I will go into other simpler things, which are some basic constants. Some basic constants. Of course, my time is about to be up, so I will just quickly go over it, okay? Because you told me it's 1 hour, so I planned for 1 hour, okay? So I am watching my time, my watch, very well, okay?
To stay with you, Dr. We have other class at 12.
Okay, okay. No, don't worry, you will not pass 12. I mean, we will not exceed 12, okay? So you have some basic constants that you are supposed to know, because you have used them time and again, that you just have to be able to remember them at any point in time. Probably nobody will ask you in your life, but probably you may find yourself in a situation whereby you may need to apply them, where they will not be provided in a problem.
Yes.
For instance, I always give example. What is the value of G, acceleration due to gravity? 6 times. Ah, you're lucky. You're lucky. It means I like you so much. What is the value of acceleration due to gravity?
Acceleration.
Due to gravity.
9.1.
No, I didn't ask you. I'm asking my friend here. 9.81. What is the unit of acceleration due to gravity? What is the unit? He said 9.81. Yeah. What is the unit? No. You see? Meter per second square. Did you see? As simple as acceleration due to gravity. We need to remember the unit correctly. The same thing. What about if I ask you density of water? You have to tell me. Yeah. What is the density of water? What is the density of water? The last guy there. Density of water. What? 1,000. The unit? Unit is very important. You don't just remember the value, the unit, because you may have different units, isn't it? Kilogram per meter cube, the unit of density, isn't it?
After we take Dr. Fluid, you should mention the temperature, Doctor. Not just 1,000. At what temperature, Doctor?
At what? No, because generally we take 1,000 to be the density of water. Of course, it is highest at 4 degrees Celsius,
yes,
which reduces with increase in temperature. But for all practical purposes, we take the density of water unless it is given otherwise. Now, as mechanical engineers, now, another simple question. What are the greenhouse gases? You are the energy expert. Greenhouse gases. You all know about global warming, isn't it? Global warming. Global warming. What do you call global warming in Arabic?
We didn't take it.
Yeah, I know, but
we know the
Exactly. This is something about your exposure to what happens in daily life. Do you understand? Not what happens also in the book. You don't restrict your life to what happens in the classroom. You need to be reading papers, newspapers, watching news. What happens today? Like, what is the new number of new cases today? Do you get my point? You don't restrict yourself to only studying books. You have to have some other life, watching news, and this is what affects your daily life. Global warming. What are the greenhouse gases? They are the ones causing global warming. Give me one. One greenhouse gas. Give me one.
Carbon dioxide.
You are mechanical engineers. You are responsible. You are in charge of the energy. Carbon dioxide, methane, and all that. So let me summarize it because I can see you are all up to go. Okay? Yeah, you have other classes. The summary of, I have been talking for the past almost 50 minutes or 40 minutes. Okay? The summary of what I want to say is I want to highlight the importance of the basic engineering concepts and mechanical engineering concepts in particular, isn't it? Most especially from mechanics point of view and from thermodynamics point of view, which form the basis of any mechanical engineering course. And I hope the message is well delivered. Thank you so much. Any question? No question? Okay.